Colt McCandless, and I am a developer advocate working at Google, entirely focusing on web games, which means while the rest of the company is off trying to optimize your search and your sharing and your mobile, I get to sit back and play video games all day, which I think is a pretty good gig. So what we're going to talk about today, which I think is a very important term moving forward over the next few generations of gaming that we've seen, is the future of web games. We've seen since about 2009 a large boom in interest from sort of small budget game developers coming into the ecosystem. In 2009, we saw the rise of mobile gaming. We also saw the rise of social gaming, and an influx, a massive amount of money and attention and time diving into those ecosystems, trying to monopolize and make a lot of money because they were new and emerging. And today we're going to talk about sort of the web as a gaming platform and what it means looking forward. Now, historically speaking, I need to give you a little bit of background of where I'm coming from, because I think it's going to set the tense for what we're talking about today. So I'm actually from the games industry. I spent about 10 years working and making video games as a hardcore graphics and systems programmer. So when I got hired on at Google to work on web games, I bring a unique perspective to it. Quite frankly, I had never written JavaScript before working at Google. So let's keep that in mind when I say some things a little bit later. This is typically, from the games industry, what we view most web development like, right? It's very casual, very easygoing. I promise I do wear a shirt at work, and most people at Google do wear shirts, but I thought this guy was pretty incentive of it. So web gaming today is really where these two things meet, right? You've got the casual nature of open web and easy development, interpreted languages making it very easy to manipulate the DOM, to create data structures, to really create graphics and make something that looks very pretty. But yet we're sort of not really bridged over to the very technical aspects of game development yet. The things that a lot of us like to forget have been around for about 30 to 40 years. We've been doing 2D game development for 30 years, right? And a lot of the techniques that made those original games on those hardware run fast are still applicable today in the web, but for some reason we forget that that knowledge is out there and that literature is out there, and we're kind of rediscovering all these things again. So when I joined Google a little bit ago, this is really sort of the hype that I kind of got in my face, was HTML5 is awesome, HTML5 is everywhere, HTML5 is the future of cross gaming, right? Write once, run everywhere. And as a C++ developer, I kind of didn't believe it, right? Like I understood a lot about interpreted languages and binary coding, and anyone who comes to the table and tells me, you know, one language is the future of all things, I kind of go like, okay, why don't you have some beer? We'll talk in a couple more minutes, right? But being at Google, I had to step back and say, let's figure out if this hype is real and figure out where the boundaries are, sort of Mythbuster style. So I set out and actually created a game from scratch. I took about 5 engineers from Google who were all ex-game developers as well. These were guys that came from the industry who had also written hardcore graphics engine, pathing engine, server technology for MMOs. I got them all together. In about 6 months, we actually wrote a top-down PvP shooter game entirely in HTML5. The game's called Grits. And we actually talked about this and debuted it and open sourced the entire application at Google I/O just a few months ago. So the interesting thing about Grits was it allowed us from a very unbiased standpoint to take a game developer's look at HTML5 as an ecosystem. Again, we are game developers who have shipped console games and PC games and mobile games, taking a look at this budding ecosystem that everyone says is the most amazing thing since sliced bread had been virtualized in a holograph system. So what we really found is you can check out the game. It's live right now, gritsgame.appspot.com. You'll also see the lol what icon in the corner. We'll actually take you to the source code. We've got the whole thing open source, including a Node.js backend that'll do matchmaking, PvP gaming, canvas acceleration, all the fun buzzwords that you HTML5 guys like to use. So the cool thing that came out about this was that once we got the game done, once we got the game up, once we did all the talks, we came to some conclusions, right? Again, different sort of perspective here. What we found were some very large hiccups in the architecture of HTML5 as a technology that really kept us from exploring and stretching the boundaries of what games could be performed. The first was garbage collection pulses. You need to understand that JavaScript is actually a garbage collected language, right? That's why you can declare var anywhere you want, and everything happens under the hood like magical pixie dust. What'll happen though is if you notice, when you start doing tons of allocations over time, and you're not really nice to the memory system, sooner or later you're going to start seeing large performance pulses that are taken away from you by the underlying JavaScript VM that are dominantly based on garbage collection. We're trying to figure out what isn't needed and yada yada. These things are actually spiking 30 to 60 milliseconds every couple frames in situations where we weren't being nice with memory, right? So we just kind of came to the table and said, hey, JavaScript should take care of this. We shouldn't worry about it. But once we started allocating about 1,000 objects, 2,000 objects, started doing 50, 60 allocations a frame, we started seeing this tick up a lot, very, very quickly. In fact, we had to take our particle system entirely out of the engine because it couldn't handle the overhead of that many objects being thrown around. And of course, there's different ways around that, but I'm just talking about the naive approach that you'd typically see with your basic Welcome to JavaScript tutorial. The next thing is number of draws per frame. This one actually surprised me. We noticed that JavaScript canvas, even hardware canvas, maxed out at about 200 to 300 draws per frame. We were expecting to get closer to what you would get in WebGL, which is around 2,000. And to put this in perspective on hardware, like if you're writing a native DirectX or OpenGL application, you can get about 16,000 to 30,000. And if you schedule everything right with instancing, probably close to about 1 million draws a second to be able to generate your scene. So the fact that we were capping out about 200 to 400 was really scary to us. And we actually had to put in, and you can watch my Google I/O talk about how we actually got around this, but we had to put a lot of stuff in to actually get around it. The third one was compression. Tyler did a fantastic job of highlighting issues of asset sizes. Since the games industry began, one of the biggest things we've always fought with is size of the asset versus size of the asset on disk. What's the size on the GPU? How resident is memory? HTML5 really does not help us with this at all. HTML5 brings a lot to the table, allowing us to just arbitrarily load JPEGs, but a lot of what 2D games need are texture blending. So we need an alpha channel that JPEG doesn't support. Because of that, we're forced to use PNGs at a lower resolution or a lower compression ratio. Of course, there's WebP on the horizon, which should hopefully fix this, but that's not yet been a standardized thing, and not all the browsers will adopt it. But that's to be determined in the future. And then finally is blending. One of the most important things in a 2D game is the ability to blend, to color tint. Unfortunately, HTML5, especially Canvas, has no concept of this. It's nowhere in the spec that you would actually need to draw a bitmap tinted a color. What? I don't get it. Right? Like, this is one of the big problems we ran into very quickly in grits. Right? We have a PvP system where you've got Team A versus Team B. For all the things we actually wanted to color tint, takes 4 extra draws per item of your avatar. So if you got the legs and you want to color tint the legs, that's 4 draws into a separate buffer that has to be then composited back in the main screen. If you want to draw the top of the robot, same thing. God forbid you try to do any sort of rotational variance inside of that too. So these 4 things, when put together, kind of create a very limited picture. Or more specifically, it paints a picture of success and where the boundaries are very quickly. Now, grits is up. You can play it. You can actually see the successes that we had and where we sort of got the failures. But the conclusion we came to, hopefully a pragmatic one, is with our sad panda faces, because we realized that HTML5 was maybe not the greatest thing since sliced bread on a holodeck. But the main thing we came to was that write once, run anywhere is really a pipe dream. Now, before you guys throw cabbage at me, let me just step back and say it again. I'm a game developer from C++ land, right? So to me, platforms are things that I explicitly code for. I expect to have a pound defined somewhere in my code base that says, are you Windows or are you Mac or are you Linux, right? So for me, having JavaScript and not having the ability to pound define out sections of code, because knowing that my platform is different, is really, really weird. But for some reason, it seems like everyone believes that HTML5 is magical unicorn dust. The truth is this, HTML5 is a fantastic standard, but what we forget a lot of the time is that HTML5 is running in a web browser. Web browsers are native applications, most of the time written in C++ code. The reason that your HTML5 emits unicorn dust into the universe is because there's a whole series of programmers sitting in a pit pounding out C++ code on your behalf. They're putting in pound defines. They're putting in code that'll make sure that your JavaScript, when written poorly, executes quickly. That does not make a platform, that makes a standard, right? I think we should all be aware of that. And I think it's worth saying that HTML5 is not cross-platform already. Anyone in here written an HTML5 website where you had to say, crap, this doesn't work in browser X? That should be everyone's hand. Like, come on, come on. Audience participation. You're in an HTML5 summit. No, you got pizza, you got beer. You're not going to raise your hand? Come on, guys. I'll raise 2 hands. The fact is this, is that people say HTML5, write once, run anywhere. HTML5 is a standard. HTML5 is an adoption. But in reality, there's this big question mark. Like, wait a minute. Why do I have a different CSS tag for gradients on rounded rectangles that can only be used in Mozilla than I have one in Chrome versus WebKit versus XYZ? It seems like people forget this. People like to come to the table with this very pragmatic or very hyperbolic statement about how amazing HTML5 is when they forget what's under the hood. They forget that it's already a fragmented ecosystem. This is a great, I don't even have to say anything about this. Hopefully you guys all got this in your Twitter feed, right? Someone else presented this. That should say it all, right? HTML5 is not a write once, run everywhere technology. If it was, this slide wouldn't even exist, right? I'm not even a web programmer. So what we're seeing, probably the most important shift in HTML5 over the past 6 or 7 months, is the exposure of hardware-accelerated items in a safe and secure way to JavaScript. What we're realizing is that the interpreted language part we've kind of got down. You can do stuff really fast. So people want to do more advanced things. They want access to webcam, USB, TCP, UDP, WebGL. The problem with this is that we're now taking heterogeneous hardware, which is known to be troublesome and already platform fragmented, and we're exposing that to something that's supposed to be standardized and run on every platform as though it were unicorn dust in the environment, right? We all saw the unicorn farting rainbows. That's not how it works. And so this is fragmenting our ecosystem even more, because as web developers approach the platform, they're coming to it with the mindset of the web rather than the mindset of a hardware programmer. Hardware programmers wake up every morning and go, what do I got to fix today on Linux? Right? Web developers wake up and they go, sweet, I get to write a JavaScript API. Like, well, that's my view. I don't know if web developers have that voice or not, or if like either way, but I know that when I started working in the game industries, I had a full, lush head of hair. It was long and it was beautiful. And then I spent about 6 weeks optimizing shader code for the PlayStation 2, and it just all fell out, right? Anyhow, anyone know this guy? Yeah. Yeah, round of applause for John Carmack. Bring it up. For those of you guys who do not know John Carmack invented the modern gaming industry. He's the dude who wrote Doom, who wrote Quake, Quake 2, Quake 3, if you're still too young to know what Quake 1 was. This guy invented a lot of the original algorithms and put them into practice in video games that gave us the industry that we have today. You would not have the Xbox 360 and Gears of War if it were not for John Carmack. John Carmack hosts there's a convention every year called QuakeCon, and John Carmack kicks it off every year with a keynote where he basically comes up and rants for about an hour and 45 minutes about whatever he wants. The cool thing was that someone this year actually asked him, hey, what do you think about WebGL? I thought it was a great question, right? Carmack and his company actually came out a number of years ago trying a new product called Quake Live, where they actually had you download Quake 3 as a plugin and run it in your web browser. At the time, they believed that this was the correct monetization model for their existing software, right? They had all of this time, all of this energy pumped into Quake 3. Why not put it on the web? Unfortunately, the web wasn't ready for it yet, and the product kind of fizzled. Even Carmack came out and said, this is a big flop. Now it's up today. You can still play it. They're still getting advertising money from it. Carmack's view on WebGL was, I think this is a great idea. But at the end of the day, you know what I want out of a rendering engine? Oh, I knew it. I knew it. I woke up this morning and I said, Mac Pushy, you are going to do something to me today? John Carmack came out and said, you know what I want in a high-performance system? The ability to manipulate binary data and get straight to the hardware with as least steps as possible. I'm sorry to tell you, that's not WebGL. All right? That's not JavaScript. I think we should all recognize that typed arrays were added at the end of JavaScript, right? It was not built that way originally. Okay? WebGL was added at the end. It's not necessarily a nice language if you want to actually iterate through a million item array. I think we just need to all be okay with that. So John Carmack actually said, you know, if you want to do these advanced things, there's other technologies out there that allow you to do it in browsers, and I think you should embrace them, right? This is the same sort of thinking that came to the table when we decided to do this. So when we talk about the future of web gaming, you need to understand, or my personal view about the future of web gaming, coming from the industry, spending time at Google, talking about the technology, seeing what's forward, is the future of web gaming is about experiences. Anyone know this? This is a human body viewer in WebGL. Now, that's actually a trick question. This actually isn't in JavaScript. This actually is barely in WebGL. All of this rendering is actually being done on the GPU. Effectively, all the points are compressed, put together, placed in a texture, sent off to the GPU. The shaders on the GPU are handling all the heavy lifting. You could do this same thing, take the shaders, take the data, and import to DirectX or OpenGL as a native application would actually be very minimal. The amount of lifting actually being done in JavaScript is small. So someone could say, hey, this is a great experience to have in the web. The ability to give someone a link and say, here, please explore my colon, right? Whee! Right? Magic School Bus goes to Colon Town. Horrible book. Do not buy that for your kids. really weird stuff, that magical school bus. Sorry. So this is a fantastic experience, right? It shows what WebGL can do and what WebGL is capable of doing. But in reality, again, this isn't WebGL. This isn't JavaScript. This is WebGL bypassing the heavy lifting off to the GPU. Again, for those web guys in here who have never done native programming, this is a concept called GPGPU that's been around for about 8 years in native graphics programming. We've been trying to offload as much of the GPU as possible in the games industry for a very long time. In fact, when the Xbox 360 first came out, this GPGPU was actually a big thing. So the fact that it's just now making it into WebGL shows some progress in the ecosystem. Unfortunately, even though we can do some things like that, this is sort of the experiences that we're limited to with HTML5. And I think Tyler's talk was a great example of this. He talked about what the limitations are. You saw some of the limitations that I saw with grits. And what it does is it forces you as a developer of an HTML5 application or as an HTML5 website to kind of program for the lowest common denominator. Right? HTML5 should be about reach. That's what the web is, right? You want to reach all 17.umpteen million billion people on the planet and get your product in front of them. Well, you can't always do that if you're targeting for the bleeding edge. And this is the problem with game development. Well, not necessarily the problem, is that it's a triple orthogonal axis. You're always fighting against features versus performance and cutting edge versus reach. If you want to put your game on the Xbox 360 and take advantage of the hardware there, that's fantastic, but someone can't play that same game on the web without serious re-architecture. Coming to these conclusions about the, hey, Dart, anyone, Dart, anybody, fans? Oh, eh. So coming to these conclusions about what the web was doing led to the development of Dart. So for those of you guys, rather, taking a step back, let's look at this again. When JavaScript was invented, it was not designed for the web that we have today. I'm going to say that again, but a little bit slower. When JavaScript was designed, it was not designed for the web that we have today. We're in a completely different place than we were when this was invented, right? We have a lot of new constraints, a lot of more data. Streaming video didn't exist back then. It does now. YouTube. How many people watched YouTube today? How many people looked at a YouTube video today? Thank you. Audience participation. Yes, I like it. The beer's kicking in. That's my favorite part. So the reason that Dart was invented by a lot of people was to approach from a new direction. Hey, what if we take all of these limitations that JavaScript has, and what if we approach it from a different direction? Instead of tacking more things on to this existing architecture that may limit our ability in the future, let's approach it from what the web is today and take a look at it from a new language perspective. And this is where Dart comes from. It's a structured web programming language. You can find it at dartlang.org. If JavaScript angers you as much as it does me, like the fact that you can type like player.health -10 and then underneath it player.heath ++, where heath has never been developed anywhere in your code base, and JavaScript's like, yeah, that's cool, you got a new variable, that's awesome, I like new variables, put them in anywhere. You know, meanwhile, I spend 10 hours trying to figure out why my rocket isn't killing a dude when it hits him in the face. Like, this is, anyhow, Dart helps with this stuff, right? So for those of you who haven't seen Dart, I'm going to introduce you to a couple important pieces of it. First off is Dart has as a nuance the class hierarchy. It comes with object-oriented programming, right? This is a concept. Game development for a long time has been built on object-oriented. In fact, that's the way things work, right? Having an entity as a base class that a player inherits from, that a missile inherits from, that a bouncy missile inherits from. This is how we kind of do stuff because game programmers are generally lazy. Right? In addition to that, you'll actually see we actually have the num class. The num class is an optional typing. You can still come to the table and actually use var and just let var be whatever you want it to be at any time of the day. But if you're in the situation like I was in, where you need health to be an integer and not turn randomly into a string somewhere down the frame for some random reason, you can actually declare it as a number. And the Dart VM will actually come back later and say, hey, 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 you're trying to assign a string to an integer. That's not cool. So it kind of adds these boundary checking into the system to keep you as a programmer legitimate and hopefully reduce your porting time. In addition to that, there's some other cool things I like about this. And again, I'm not the Dart guy, I'm the web guy, but I wanted to do a quick walkthrough here. Import dart.html. This is interesting. The concept of being able to import other libraries, the concept that there's modules of code that you're going to want to pull in. How many of you have typed script source equals jquery.min.js, right? A million times, right? That's the same concept. We're already bringing the concept of modules to JavaScript. We're just sort of tacking it on. Dart makes that a first-class citizen. And of course, they've sort of tackled the DOM, again, from sort of a first perspective, like, hey, what do we do with the DOM, how we do it. The point of Dart is that, hey, maybe JavaScript works for a tier of experiences. And maybe we need other technology to get another tier of experiences. right? If we can only draw 200 to 500 canvas sprites a frame because of the limitations of JavaScript, maybe we should take it to another level. And this is where native client comes to the table. For those of you who don't know what native client is, native client is a technology that runs in Chrome that allows you to run C++ code in a web page as native code as securely as JavaScript. And that's the kicker, right? There's been efforts in the past to try to run C++ code in a web page that may not have been the most secure implementation. Maybe there was a lot of malware involved with that process. Native client from the ground up is built first for security. Now, the cool thing about native client, what you're looking at here is an actual native client game that you can play in the Chrome Web Store today called AirMech. AirMech is a full player versus player real-time strategy game. So if you're a fan of StarCraft, you're a fan of Warcraft, Command & Conquer, go try AirMech. It's fantastic. Fully 3D rendered, all hardware acceleration using SIMD, L2 cache optimization, and actually running assembly code, hand-optimized assembly code, because native client allows you to do that. This is a separate tier of experience that you can only get when you embrace a new tier of technology. And that's what native client brings to the table. Now, here's the really cool thing that I want to spend a little bit of time talking about in the concept of the future of web gaming, right? So we talk about these classifications. So today, NACL just compiles to x86. And it compiles down, and that's what's cached on your machine, and that's what's ran exactly. We don't necessarily like that because there's a whole classification of devices coming out in the future. I mean, we've already got ARM out in the ecosystem. Who knows, you may get Armicle or something in the future. The Borg may design some new thing. So we actually have something coming down the pipe that you'll see the first drops of, hopefully Q1 of next year, called Pinnacle, or Portable Native Client. Now, Pinnacle works a little bit differently. Pinnacle will take your C++ code and actually compile it to LLVM, which is sort of a open standard virtual bytecode system. And then from that, when you actually download it to your system, it'll hot convert it to whatever your lower underlying architecture is, which means it'll go to ARM or x86 or whatever comes out in the future, right? It's supported. It's sort of our version of the open standard, right? Here's the really cool thing about this. This means that you can now use any language that compiles to LLVM to program web pages and high-performance web applications. You like Python? Cool, put it in a web page. You like Ruby? Cool, put it in a web page. You like lol code? My personal favorite. Put it in a web page. Have fun with it. As long as it goes to LLVM, you can now put it in your web page, which means the future of web gaming is not about the language. I think the web community has spent too long arguing about, does NACL work? Should it be adopted? What is JavaScript? How important is that? JavaScript will get us too far. It's not about the language. It's about the technology matching to the experience, right? Especially when you look at it this way. What if we allow all these technologies to work together? Let's say we've got a game code, sitting around running Dart or JavaScript. Let's say it's doing some interesting stuff. And let's say we have a module running 3D physics in native client, and these two can communicate to each other. Now you're in an interesting situation. You can do the flexibility of writing your code in JavaScript or in Dart, all the DOM manipulation you want, but the physics are actually calculated in native client, and you can get the results back and update your scene hierarchy in WebGL. So now we're getting the ability to accelerate the parts of your web application with the code that's going to actually do that. You're not locked into one language. These things can communicate back and forth to each other. This is an actual demo done by one of our DPEs at Google named John McCutcheon. And what he's actually doing is this is literally a Dart engine running all of bullet physics in native client. And in bullet physics, all it does is just pass over the objects and the rotation and the hierarchy back to WebGL, and WebGL displays it on the screen. This is really cool. Imagine if, instead of including jQuery on your page, you could include an entire physics engine, or a video decompressor, FFmpeg. Or what if you have an audio modulation system that you can include in your web page for your users? Now we're starting to get into really exciting parts of the web. We're not bounded by one language. We're bounded by what the experience should be for the user, and that's what we should be focusing on. Can we do this? Embed source equals bulletphysics.nacl. That would be really cool if jQuery, if it was as easy to implement these things as it were, including jQuery. This is my big vision. If we step away from the language and we focus on the experience, then we realize that the games as an industry has been growing in the number of assets over time. Today, it generally costs about $40 to $60 million to produce a game on the Xbox 360. Unless you're indie arcade, and then you really just live off of peanuts and pizza, but that's a separate discussion. Because those costs are so high because of how much it costs to produce the data involved, right? And I think we can all agree that this is not unique to game development. I think it's OK for us to admit that the web has and always will be all about data. Gaming has been all about data, especially that guy, especially if you grab him in the raid. He's actually pretty hard. But with the new expansion pack, he's not in the raid anymore. He's off wandering the existence, trying to find the ethereal. You know what? Just play the game. Anyhow, the point is, if the future is all about assets and experiences for the user, then we have to come to the conclusion that data drives that experience, which means we as developers, as web applications, need to understand how data changes the way we look at the ecosystem. For instance, World of Warcraft, I think, is around 40 gigs of content right now. Let's say you were to make World of Warcraft a web application and somehow got it into 1 gig of data. Sending that 1 gig to a user, if you required them to have the full 1 gig before they were allowed to see a single pixel on the screen, would take about 7 minutes on a 20 megabits per second connection, if you're lucky, and within 100 miles of the data server and have perfect up connection with no caching. Yeah, I think I got all this right. If you gzip that, hopefully you're gzipping the data, right? Like you're not sending raw text around. You can actually get that down to about 196 megs, which of course will change it to about 2 minutes transfer time. So now here's something that the web knows about, right? It took a long time for web developers to understand, wait, compression is important, bandwidth is important, how long it takes an asset to get from my site to the user is super important. And everyone started putting in this compressed gzip stuff. So you can set a flag on your server to gzip the assets, it'll gzip it on your behalf, and the web clients will decompress on your behalf. The problem is that this is using gzip, which for all intents and purposes is not the most aggressive one out there. If you look at the cutting edge of compression, probably my most favorite is LZ-HAM. It's actually an open source thing. You can go grab it off of GitHub. It'll take that same 1 gigabyte of data. Actually, that's inverted. Sorry. That's supposed to be 204 for gzip and 130 for LZ-HAM. Can we cut that out of the video? No, we're live. Oh, everyone applaud for the live internet, I guess. I don't know. And 1 guy. Awesome. My point is still the same. It's the beer. Anyhow, LZ-HAM at the proper value actually takes about 1 minute and 18 seconds to transfer. Now here's the important part. We're not just talking about transfer times, which directly relate to user experience, by the way, right? Everyone knows that the web is ruled by 3 seconds. If your data is not loaded on your page by 3 seconds, everyone GTFOs, because they know that they can go somewhere else and get pictures of Lawrence Fishburne or whatever the flavor of the month is. I'm not even going to say. So we're not just talking about transfer times. We're talking about costs too, right? To transfer 1 gig to 3.4 million users a day, which, by the way, is the average number of users that may, how do I say this without saying this? The number of users that may visit a very popular social game that involves stacking pink cows on top of each other, right? If you're doing a good social game like that, you're generally seeing about 3.4 million users a day. Unique or not, let's just use that as a number. Now, to transfer that 1 gig to every one of those 3.4 million users is about $9,600 a day. Now, hopefully, if you're getting 3.4 million users a day, you can cover that cost. But this isn't a big number. Compressing that down with gzip gives you about $2,900, and LZ-HAM gets you down to about $1,900. At this point, you have to start asking different questions about your data. Does the 1 gig need to go to every user? We have to think about the data differently based upon the experience, right? Here's the most important part about this, is that because of the fact that we have gzip as a default implementation in the browser, let's take a look at this from a different angle. So what you're looking at here is a graph of gzip ported to JavaScript versus gzip ported to native client. Okay? So the y-axis here is the microseconds it takes, and the x-axis here is the number of runs over time. So basically, we just decompressed 1 gig compressed of a bunch of different data sets, right? You can actually see that not only is the JavaScript version way higher, it's really spiky. You can see that the underlying hardware or the underlying virtual machine is trying to figure out what the heck you're doing. What are you doing with this binary array stuff? No, we don't do this. We like DOM. It's fun. Where the knuckle stuff is very consistent and very low keel, right? So when we start talking about the evolution of the web and the data that's coming through it, we have to look at the technologies that are going to enable us to experience that. So having the ability to do LZ-HAM in JavaScript, can't do it. Putting LZ-HAM in native client, that's cool stuff. You're going to have a good time. No South Park fans in here? If you bring LZ-HAM and you put it in knuckle, you're going to have a good time. Great game, Realm of the Mad God. Anyone played it? Round of applause for Realm of the Mad God. This is a gaming meetup, and like 6 people have played Realm of the Mad God. Realm of the Mad God is an amazing... Serious games. You shoot orcs. What? Come on, serious? Okay. Serious games. I'm going to shoot an orc with an arrow and then go loot the body for a bone from a ferret. And this is my Saturday night. Really, we're going to talk about serious games? Sorry. Diatribe. All right, Realm of the Mad God. Realm of the Mad God is a fantastic game out on the internet. If you haven't played it, go play it. It's a great monetization system. Coolest part about it, it's only 1.29 megs for the whole game. It is an endless MMO. It's actually a full 2D, massive multiplayer game where you run around and shoot people, right? It actually hosts probably, I think they said their numbers were above 64,000 people on a server at one time. Like, it's a huge thing, all fitting in 1.29 megs. If you transfer that to 3.4 million users a day, this costs you $12. This is thinking about data and experiences differently, right? They're coming to the table, they're understanding what's important. 1.29 megs transferred to that many people, it loads up quickly, it gets down there, and it costs little. Which also brings us to the next point. The future of the gaming is about connecting with the user. I love this story in the modern ecosystem. Gaming today, unfortunately, is about digital distribution silos. People spend a lot of time as a game developer trying to figure out how to get optimized and featured on this little 96 pixels by 128 pixel screen on your phone. And they spend a lot of energy and a lot of money and a lot of time fighting to just get that little piece, completely ignoring the fact that they can advertise to you as a user directly, right? Gratuitous Space Battles is a fantastic game that's distributed through a service called Steam. The maker of the game, Positrek Games, actually allows you to buy this game, their game that they've made from their website. In fact, this has been one of the big things about their success over time. If you go to their website, he has tons of buttons that you can click on to give him money. He makes it super easy to click a button and hand him your hard-earned cash because you can get that, right? He is enabling you as a user to get his content through the internet. He's connecting you to you in a different way. And I think this has been the future of web games. But we've been locking ourselves into social silos and digital distribution silos and really missing the fact that as a game developer, you have the ability to connect to the user. How many people are marketing majors? Awesome, perfect. I'm talking to the right crowd then. Marketing majors are idiots. No, I'm kidding. Marketing majors spend a lot of time talking about region of interest and how do I track a user and how can I make more users get to my product. Marketing people hate the current state of the gaming industry. You want to know why? Because if I spend $10,000 buying an ad to promote my game that exists on a mobile ecosystem, I can't push it to my game. I got to push it to someone else's hub that has details about my game that then you got to go through a click-through flow that maybe you'll buy it after that. Wouldn't it be better as a marketing person to put that money and drive you right to the website where, hey, look, you want to buy it with Amazon? Cool. PayPal? Cool. Google? Cool. Give me your money, please. I'm an independent developer. Positrek Games goes even farther. I love this. He says on his website, hello, I'm a human. If you buy it from my website, I make 91% of the money, right? I think we've all seen that a lot of social platforms as well as mobile platforms take cuts in percentages. He comes out and says, please buy from me. I get 91%. I'm a human. Guess what? I have cats. I need to feed my cats. This is literally on his website. You should buy from me because I have cats. Better yet, here's a great thing. He says right here, even if you don't buy from me, give me your email. I'll send you some cats. That's internet marketing 101, right? When have cats will get email. Even if someone just says, sure, I just want cats, he's now got an email address that he can market to over time. Hey, by the way, I just added a new cat unit in my Gratuitous Space Battle game, and I'll sell it to you for 50% off because you like cats too. This is marketing. And a lot of game developers are coming to the table today knowing nothing about it, completely forgetting about it. The internet and the web is all about marketing, and game developers can break out of the shackles of these ecosystems that are keeping them from being successful if they only embrace connecting with the user at the level. And the real reality is that the future of web gaming is about connecting users together. Here's a great flow. And someone in the audience is going to raise their hand after this. I know it, but I'm not going to call on you. Let's say I'm on a website, random website, don't really know what this website is, just randomly took a picture of the internet and photoshopped it. And let's say I've got a button on the website that says start a game. Let's say randomly that start a game gets sent to some user who may have another device, don't know what this device is, just randomly took a picture for some device, that allows me to click, cool, I've been invited to this game. And then I can play these two things together across devices. This starts to get interesting. Native Client enables a new round of playing here, right? What you're looking at is actually a game called Star Legends that's running C++ code on Android as a native application and running native client code in Chrome, right? Because of the same floating point model, because of the same system, you can actually do this. I'm not saying they do. I'm not saying you should go Google how to do this. But I'm saying like what you're actually looking at here is this player is actually that guy, right? They're allowing multi-screen device. This is the new trend in the industry that we're seeing. Single narrative multi-screen, single narrative multi-device. And with technologies at these experience levels that we're talking about, you can actually start allowing users to connect with each other in ways that we never thought about before. World of Warcraft has another great example of this. They have something called the mobile auction house, right? So you can go kill this massive 30-legged creature, right, and then get the loot, and then pick up your phone, or turn off your computer, go stand in line at the DMV, wait to get punched in the nose, because that's really all the DMV is there for. And while you're standing in line waiting to get punched in the nose, you can sit there on the auction house and sell the things that you just got. This is connecting users in new ways with new devices. And the fact is that this isn't anything about the client-side technology. This is all about the back-end technology. This isn't about the language. It's about the experience. It's about the data. That's what the future of web gaming is. And so with that last slide, and I know this is where someone raises their hand, I'm going to add this caveat. Write once, run anywhere is a pipe dream for now, right? Being able to write in C++ code and distribute on Android and write in C++ code and distribute in native client, that's kind of right once-ish. I'm going to have a pound to find. I'm going to have to wake up in the beginning of the morning and go, what do I have to change today to make sure that this will run in a 16:9 ratio running on a Radeon from 6 years ago that may only have 64 megs of memory on a GPU. That's the future of web gaming. Game development's hard. We should understand that. But goddamn, is it fun. Thank you for your time. My name is Colt McCandless. This is how you get a hold of me. I think we got room for, you can applause. Yeah, applause. Yeah, clap it up. I love it. We got time for questions?
Time for questions.
Yeah, cool. Questions? Please speak in the microphone because I hear horribly and I'm bald. So the question is, where is native client? I haven't been hearing a lot about it. Over the past 13 months, we've shipped over 24 games to the Chrome Web Store that using native client technology. And you can actually go to gonackle.com. We've got a brand new updated developer kit that includes a Visual Studio add-in as well as Eclipse support that allows you to develop this stuff and get going. We've also got postmortems from all of these developers that talk about their experiences, the pros and the cons, where they hit speed bumps, and how you can actually learn from their mistakes moving forward. The fact is that as a development platform, we are hyper and aggressive about improving the developer experience, because right now it's a little too hard, and we'd like to fix that. So your second part of your question was, why am I not seeing it in other browsers? To that one, I just kind of got to go like this. Chrome is open source. Native client is open source. I think we can all agree that since Chrome has been open source, we've seen other browsers adopting some of the things that Chrome really does well. How many of the other browsers have automatic update now? That's kind of cool, right? All we can do at this point, I mean, we can't force these other browsers to implement native client, right? We can't go to the table and expect them to do that. All we can do right now is show them how amazing this technology is and what it can do to change the way people experience the web and hope that they see the value there. So, follow-up question.
Yeah, so is it going to be in WebKit on Android anytime soon?
Is it going to be on WebKit on Android anytime soon? Those are two words that I am not the right guy to talk to about. So if you want to talk about games and the word Chrome, I can help you out there. No, we got a question in the back here.
Just to set the context, let's say I care only about targeting Chrome. And
then I like your style.
Yeah. Games.
No, I like your style even more.
Yeah.
Yeah. That was an uneasy laugh that rolled through the room.
And I could take, if Google supplied a native windowing kit, that'd be fine, but I could live without it. But the thing I wonder most about is there any work to have an official bridge for Golang and Pinnacle?
Golang and Pinnacle. Oh, that's a great question.
There's a discussion threads, but I just wonder if
yeah, so I don't have visibility into Golang. I think it uses Clang as the backend compiler, right? No, what does Golang use?
Its own
Oh, cool. So cool. It uses Frankenstein mode. That's awesome. Thank you, person in the front row. Really, we don't know just yet. That's the cool thing about Portable Native Client is that as long as your LLVM code comes out to obey these specific rules, we'll be able to hot compile it to whatever the underlying architecture is. Again, Native Client and Portable Native Client are all open source. If you happen to be a genius in Golang and LLVM and you would like to contribute that to our ecosystem, we will welcome you with open arms.
And then I'm not the genius, but you guys have some, so are they working on that, or is that something?
Again, Golang's not in my vocabulary ring. Sorry, he was asking, Google's got a bunch of geniuses. Are you specifically working on that? No reporter from the New York Times. I do not know about that. Sorry. I get those weird questions like, is Google taking over the planet? Games. Thanks, Peter. Great question. He said, in native game development, if you're shipping Xbox 360 or any of those things, there's usually a rich set of tools that you use to create content, create scripting languages. What are you excited about in web games, and what tools are available out there? You know what I'm super happy about? I'm happy about the same tools that I use for my native game development. There is nothing keeping you as a developer from using Maya or 3D Max or your scripting language and exporting it to a data format that can be read in JavaScript or native client or Dart. Like, I want to make sure everyone understands that. Like, there's nothing keeping you from using these existing rich, lush editors and content creation systems that have made video games so popular over the past 30 years and taking that data and putting it on the web. There's no barriers there, right? You just got to transform some data. So if there's nothing really exciting I see, like, sorry, I said that wrong. Like, when I look at it from that perspective, I kind of ignore a lot of the stuff that's geared only for HTML5 or geared only for ActionScript or stuff like that. Because from my point of view, you know, that's sort of a domain-specific thing. I can still use Maya. I can still use scripting. I can still use Max. I can still use all of these things that I put together that I've known and game development has used. And there's a million books and tutorials and examples of out there. There's more education out there than you'd expect for game development. I think you had a question. Okay. Or are we all done? Are we done? No? Sorry. I should. OK. All right. Hey, thank you all so much for today. I appreciate your time.